So about a month ago, I posted a video about the install of my LightLeaf solar panels. And if you watch that video in the first couple days, there's a short clip that I've actually trimmed since then, but you would have heard me say this. And as I drill the holes, I go ahead and attach the brackets. For the final install, I will be using Loctite and lock washers, kind of a belt and suspenders deal. So here's what happened. Wednesday of that week, I actually finished the install. I think Thursday night, I finished a video edit, and I had scheduled that video to go live Saturday morning. But sometime during the install on Wednesday, I decided to get some tamper-proof fasteners. Basically, if someone wanted to steal my solar panels, they're going to be able to do it. But I thought by getting these different fasteners, if you're an unprepared thief, perhaps, you'd have trouble unscrewing them. So that video went live Saturday morning. Saturday afternoon, my fasteners finally showed up. And then Sunday, I actually got around to replacing the fasteners. And that's when I noticed a pretty major problem, and that was cracking around several of the mounting locations. So I immediately sent LightLeaf an email, and we were just like all scratching our heads. All my experience with polycarbonate is it's like the plastic you use when you don't want stuff to crack. They told me about a trailer company that uses these as basically like rock guards. So when the trailer is getting towed down the road, rocks coming off the rear tires don't crack the windows in the trailer. Like none of us had ever seen this before, and we were all scratching our heads. So what happened? Turns out, like in a single statement, polycarbonate shouldn't be used with common thread lockers, or maybe the reverse should be stated there, that common thread lockers just shouldn't be used with plastics. This was a newsflash to me. This was a newsflash to LightLeaf. In the next couple days, after I'd been communicating with them, one of their engineers actually duplicated this in an experiment in the lab, and I guess they had cracks appearing like within 10 minutes of essentially using the thread locker I did with the polycarbonate sheet. So to me, that was like super surprising. Like none of us had heard about this, and it seems like such a catastrophic kind of relationship that I feel like the internet should be full of kind of examples of this happening. You type this into YouTube, I can't find any videos that pop up about it, and then maybe most evidently, no one decided to comment on my video that this was a terrible idea. I mean, I think usually in a video, if you do something that can even be a little off, people will definitely take the chance to tell you about it, but nobody commented about thread lockers and plastics. That said though, if you go to the Loctite technical data sheet for the Loctite 243 that I used, under general information, it does state this product is not normally recommended for use on plastics, particularly thermoplastic materials where stress cracking on the plastic could result. Now, even if I had read this before my installation, I would have even assumed this is talking about application where either you're using like plastic bolts or like plastic threaded fasteners, not actually the thing it's holding. I would have not foreseen that the fact that the thing you are mounting with metal fasteners that have thread locker on them could cause the plastic to become brittle. So today's video is going to be like part follow-up to the first LightLeaf video I did and like part science experiment. I'd like to try to kind of duplicate this polycarbonate Loctite interaction here in the shop. I think Loctite, as far as I know, cures in the absence of air. It's an anaerobic process. So is it like just the contact with the uncured Loctite? Is it like something in the curing process that's causing the brittleness? Or is it like even if fully cured Loctite comes in contact with polycarbonate, can it cause some kind of brittleness? So I'd like to kind of play around and just kind of see what part of that process causes this and just kind of run a little science experiment, you could say. But before that, there was a few comments on the first video that I made I'd like to address. I want to just clarify a few points on my install for people going forward. And then on my new reinstall, I am doing a couple things differently. Obviously not using Loctite, but a couple other small things, so we're going to cover that as well. But first off, before I say any of that, to LightLeaf, I think I got to say sorry and thank you. I mean, it is clearly my installation that caused this failure. Like I'm the one who put the Loctite on there, and it's been kind of a tough learning experience for us all. I mean, they were great. We communicated daily for I think like 2 weeks almost, going back and forth, kind of trying to brainstorm things. And they were great to work with, and they did right by me. I mean, they sent me new panels for like a mess up that was clearly part of my install. That kind of customer service, I think, is just above and beyond. And it's been great, just communicating with like actual people that work at the company, not some kind of call center, no middleman. Fantastic company to work with. LightLeaf, thank you so much. Sorry I broke your panels. I still love them, and I hope to use them on my van for years to come, so thank you so much. So with that, let me first start by addressing a few of the comments from the first video. So first off, I had a few comments specifically asking about SIG solar panels. Some people just wanted my opinion on them. Some people seem to completely love them. And they have great shock value, I think. I mean, the marketing on these, like, I've seen the videos of people driving over them. Someone referenced a video where I guess someone shot one with a gun and it continued to output. And I mean, that really gets a lot of buzz. That's like very exciting marketing. But I think it's like completely unrelated to reality. Like, my problem with these solar panels is not that like I got up on my roof and like hammered at them and they fell apart. It's like that day in, day out temperature cycling and the layers delaminating, eventually leading to failure. And if you read reports about SIGS panels on the internet, those have the same delamination issues as far as I can see. Plenty of people have had issues with them delaminating, so they're just same kind of failure method. And I know people will say, oh, but look, they continue to work even after they're damaged. That doesn't matter to me. Traditional flexible panels as well, they continue to have some output, even though you can clearly see that water and stuff is getting in there. And I don't want to travel with a product that I'm like, wow, I'm impressed it's still working, even though it's on its way to failure. I just want a product that works. I don't think SIGS panels are the answer. If you're looking for a panel that you could like roll your van onto and they continue to work, that's great. For me, like that's just not like a realistic parameter. I think they're going to fail just like all the other panels from what I've seen at this point. Onwards, I had a comment about like the polycarbonate front sheet and like the lifespan of it, and that is a legitimate concern. Polycarbonates do haze, do yellow over time, but the person that wrote this, I think, didn't actually go through and read the specs, and that's like one thing I really liked about LightLeaf is I think all the other companies with flexible panels and stuff, they just throw out these marketing terms like UV resistant, you know, will last a long time, but they don't really back it up. And so when I looked into the LightLeaf panels at first, they were super transparent, pun intended about this, and that's because they just spec exactly the polycarbonate sheet they're using, which is a Lexan HP12W. If you go into the specs on that, there's a lot of engineering jargon. A lot of it was actually over my head too, but I just kind of try to look for information that I think is applicable to me. So there is like a test for yellowing index, as they do like accelerated aging tests. So kind of 2 points that really helped me resolve this in my mind, I guess, when I was looking to buy them, is that I found out that a change in yellowing index of like 5 or less is usually not perceivable by the human eye. And then I found this graph between Lexan HP92W, which is like the same family of polycarbonates versus regular polycarbonate that's not treated. And you can see how much it slows down the aging. So sure, these still may not last as long as like traditional glass panels, but I think for the application of a camper van, which is like 10, 15 years, I think these are going to do just fine. So, you know, that comment, I feel like just inform yourself, I guess. That's what I did. That's what made me believe in this product and made it worth for me to buy them. And then just very last point, someone asked about the vertical height of these, like the curvature if you lay them on a flat, how tall is that? That's actually one of the specifications I couldn't find on the LightLeaf website when I went to buy these. I did email them about it, and they sent me this basically schematic. So that is, I think, just under 42 millimeters or just over 1.5 inches at the high point in the curvature when you lay them on a flat. So on to the science experiment portion, you could say. These are the 5-thread lock. Hey everybody, Paul from the future here. I'm sitting down editing this video, and a couple things I want to bring up. First off, the science experiment portion of this video. There's actually quite a bit of interesting footage, I would say, but it's quite long-winded. So I think I'm just going to release a kind of a separate video with just like all the raw footage so you can kind of see it all. And then I'm just going to kind of consolidate what observations I made, so it just makes the video flow a little better. And then unbeknownst to me, as I was editing, or as I was filming that last segment, talking at the bench there, my idea of how I was going to reinstall my panels totally went off the rails. Total shit show. That's like the only way to describe it. And I just made some poor assumptions into the process I envisioned for remounting them. So after I present what happened with my little science experiment, I'm going to just kind of take you through that saga. So stick around if you're interested in that. It's not the work I'm most proud of. There was a lot of just like, you know, kind of, I like to have a plan when I take on a project, and I felt like a lot of what I was doing was just like reacting to poor choice after poor choice of like trying to force a design that I didn't think through all the way. So anyways, if you want to see that, watch to the end. But I think for the learning portion, let me just present to you what I found out as I was playing around with these Loctites and polycarbonates together. So for this pseudoscience experiment, I took a sheet of polycarbonate I purchased locally and then cut it into thin strips to see how they would be affected by varying degrees of exposure and contact to Loctites. In my shop, I have 5 different Loctites I like to use regularly. Blue and red, you know, commonly referred to as like medium and high strength in both a liquid and glue stick form. And then this green Loctite, which can be dribbled onto a fastener that's already in place, and then it will actually wick down and through the threads and cure. I really like the glue sticks for working around things you don't want to accidentally stain, like specifically upholstery or countertops. But if you read the technical data sheet for these, they all have that disclaimer not to be used on plastic. So I'm not going to just extensively test all of these. I'm just going to assume that they all are not a good idea to be used on plastics. And I must make this disclaimer. I'm not looking for a way here to continue to use Loctites around plastics. I'm just really curious about this behavior and this interaction between the two materials, so that's why we're running this little experiment. For reference, here is bending a piece of uncontaminated polycarb. It's like a truly amazing product. You expect it to just shatter as you're creasing it so tightly, but it just bends. Even using something like a spring punch to try to crack it, it just dents. Well, look at what happens with acrylic when you try the same thing. It shatters and has cracking immediately. So here are some observations. Number one, uncured Loctite doesn't seem to affect the polycarb. I placed some 243 blue liquid and some 248 of that blue glue stick inside a little aluminum channel here, and then I placed the polycarb just above it. So if there was any off-gassing from that Loctite, I think it would affect the polycarb, but without any contact, these seem just fine. They didn't seem to be affected at all. Then I took a couple samples and I actually dripped and smeared the Loctite right onto the polycarb, and this also seemed to be completely unaffected. When I went to bend these, they performed just like the uncontaminated Loctite. So based on this, I'm going to conclude that uncured Loctite does not affect the plastics. So that brings us to our second observation, which we must conclude then that something about the curing does affect these plastics. So for this, I tested two different scenarios. I called one non-contact NC and one contact C. For the non-contact, when I put the fastener through the piece of plastic, I tried to avoid having the Loctite actually contact the plastic at all. And then for the contact, I made sure the Loctite was contacting the plastic. And then put the nut on and then left this in place for, I'm not sure, I guess it was about 30 hours just to see the results. The non-contact version had one tiny little radial crack, and the contact version had a ton of cracking, exactly like I had seen on my solar panels. Here is the 248, radial cracking all around. 243, it actually has less cracks running out, but as you can see, this one actually goes all the way to the edge, and you can actually feel the little gap there, like this whole triangle has kind of, seems like it expanded out or something. Third observation, I also tried to pre-cure some of the Loctite using these long coupling nuts. After about 12 hours, I undid the coupling nuts and then I placed them through the plastic. Now there was just a tiny bit of uncured Loctite right around the head of those bolts, so I tried to remove all that as well as I could before I ran it through the plastic. The result was, when I first inspected the samples, there was some tiny radial cracking around the hole in the plastic, but inconsistently with all the other observations, this was the only sample that actually seemed to become brittle and crack. When I went to bend the sample that had been with the 248 Loctite, it actually snapped. Unlike all the other ones that, even though they showed that radial cracking, they actually were still somewhat malleable. When I went to bend them, the plastic between the cracks seemed to not actually become brittle. So then really briefly, I also did try that 290 penetrating thread locker on one of the samples, and this didn't show any micro cracking and didn't seem to affect the plastic at all. Not saying it should be used, but it didn't seem to affect the plastic at all. And oddly, the bond strength that this gave, I mean, it was a pain in the ass to undo that fastener. It was a substantially stronger bond than the blue thread locker had produced. And just to retouch on that third point really quick, that's a really kind of bizarre to me, like, material behavior. Where those cracks are, I just assumed that all that plastic kind of in that diameter or that like proximity to that hole would become brittle. But even using like the spring punch after the cracks had formed, when I try to spring punch the area just between the cracks, it continues to not shatter. So that's just like a really, I think, interesting material property, that you've got these cracks propagating, but the plastic is still seems to be just as kind of crack resistant as I usually expect polycarbonate to be. Really interesting observation there, I thought. So what is my final observation here? If you are a chemist and you know more about this, then you should just chime in the comments and like enlighten us all. But from what I'm observing is that when you look on the internet and it tells you that Loctite cures in the absence of air, being anaerobic, this is an oversimplification, and I think it is anaerobic maybe in how I remember in biology class, like anaerobic exercise, lack of oxygen. I think it's actually the lack of oxygen that's causing the curing process. So basically what's happening is that the Loctite is curing in the absence of oxygen, but it is actually off-gassing itself, and something about that off-gassing is causing the polycarb to become brittle. What led me to this conclusion, I guess I would say, is that when I undid one of the contaminant samples, the little piece of thread that's basically in the thickness of the plastic, so between the bolt head and the actual nut, there was still uncured Loctite in there, because in that little cavity there wasn't an absence of oxygen, but the off-gassing from the Loctite that was curing inside the nut, like thread portion, had caused that plastic to become brittle. And when I think back on my solar panel install, I mean, this was kind of like a facepalm moment or whatever people call, because basically the first time I put my fasteners in, like the non-tamper resistant ones, I used Loctite on those. That caused some of this cracking. And then when I swapped to the tamper resistant fasteners, they were just lathered in more Loctite. So I essentially caused this process twice to break down that outer sheet of my solar panels. So anyways, to me, at least that's some pretty fascinating kind of material behavior there. So now let's talk about the swapping and reinstalling of my new set of LightLeaf solar panels. So here's some insider beta, you could say. When I'm prepping for one of these videos, I'll make a little Word document that will kind of help keep me on track, make sure I get the shots I need. So for this reinstall, I thought this panel swap was going to be like extremely easy. So I actually wrote out the simplest 8-step plan for how this was going to go. You know, remove the old panels, drill out the old riv nuts, make a jig to drill the new solar panels, transfer the holes onto the brackets that are on the roof, drill the holes in those brackets. Then I had these foam spacers on one and on the back of the panels, mount the panels, do the wiring, and we're done. I had basically allotted an afternoon to get this done. And right before I started that reinstall, I actually recorded this blurb describing how I want my new brackets to function. And it has some real, just like classic comical, like hindsight is 2020 in it. So the original installation, if you watch that video, the brackets I made, they sort of had this shape to them, and then went like this. This surface here was glued down to the roof of the van. This little top flange was bent to kind of follow the angle of the panels. There was a riv nut that I had installed here, and then as the panels would lay across it, you know, they've got a shape, kind of gets a little thicker right after that. Then I would have my threaded fastener with my bolt, and it would come through here, and then the thread locker I applied to the threads right there, that's what caused all these issues. So here in the revamp, the plan is to get rid of these riv nuts. We're going to drill them out and then just try to get nylon lock nuts on the underside. It's going to be a little bit of a pain to get a wrench underneath there. But that way we'll have no thread locker. Nylon lock nuts I think work well for this application. So that's the plan. Now, something that happens to my brain in situations like this is I can say that all the evidence I have supports that the Loctite is what's causing this issue, but then my brain kind of goes into this mode where I am now on a mission to prevent cracking from any sort of mechanism possible. So if it's not this chemical process, the other way is like mechanical cracking, and there's no evidence to support that I need to like take this into account, but now my brain has fixated on preventing this cracking. So not only are we getting away from the Loctite, other things I'm doing is this washer on top. I've specifically purchased washers that have like a foam backing so that the load spread across this top here is like more evenly spread out so we don't accidentally develop a crack. As I've shown, polycarbonate doesn't crack really from mechanical forces alone, but now I'm obsessed with preventing it for some reason, like my brain will do this. And then between the bracket and the panel, I'm also going to have a little foam spacer in here so that this whole sandwich, there's just a little bit more flex in it just to essentially solve a problem that wasn't a problem. But that's just how my brain works. It's now decided to create this issue, and now I am planning my build around something that wasn't an issue. But here's how things actually went. Steps 1 through 6 were great. I drilled out the old riv nuts. I modified my old jig, which was still in like my scrap bin. I drilled the holes in the panels. I test fit the panels and then transferred the holes to the metal brackets. I drilled the holes on the roof, and I added the foam spacers to the back of the solar panels. And then I moved to step 7, which was to mount the panels. And this entire process up to here had been planned around this assumption I had made that I could get my fingers and some tools underneath the solar panels to hold the washers and the nylock nuts underneath there so I could secure these things down. And suddenly it just wasn't fucking working. I don't know, 8 or 10 hours of my life was spent after this, and I just got progressively more and more pissed off. And I tried things like I welded some wrenches together so I could actually get that lock nut underneath. I went to gluing my washers and my nuts together so that I could actually try to control their alignment underneath. I tried pre-gluing the fasteners to the brackets with hot glue. Nothing was working. It was an extremely infuriating process. I think at the best case scenario, I got one of my fasteners tightened only to cross thread the one next to it. And at that point I had to pull the first fastener back out so I could re-glue the second fastener into place. So this was just an infuriating, this is like an infuriating day of my life. And all of this was just to, as I said at the beginning, fix a problem that didn't exist. There was no evidence that it was mechanical stresses, and I was just redesigning my bracket design to prevent cracking from mechanical stresses, which wasn't what was hurting my panel. So this was just a phenomenal waste of time. So at this point, I basically had kind of backed myself into a corner. I had already drilled the panels. I had already drilled the brackets. I couldn't just like reinstall the riv nuts in the original holes, and I just didn't have enough aluminum to just remake the brackets. So I went with the unprofessional and painful looking decision to install riv nuts into the new holes I had mounted. I had planned to downsize to M5 instead of M6, partially because the washers I had planned to use, those little rubber backed washers, the ones that are available in M6 were so much larger they would have not worked. So I had already decided to go to M5. So I installed M5 riv nuts into all the new holes I had drilled. Not a very professional look, but it was basically my only solution that I could accomplish right now. This though added new difficulties. Basically, when I had planned to use the nylock nuts, I knew I didn't need very much like squeeze force, but now that I had to actually use the tooth washers for as like a lock nut, I needed to tighten my fasteners down quite a bit more. So now that foam spacer on the back that I had installed was actually going to cause the solar panels to kind of deflect slightly along the rim to actually get enough downward force on the fasteners. So then I had to scrape off all that foam. The adhesive on that foam is incredible, so there was no way to just peel it off. And with already the phobia of messing my solar panels up with chemicals, I didn't want to use any kind of adhesive remover to risk discovering a new way to destroy these panels. So I just kind of left that foam residue there. I'll never see it, but just not professional work as far as I'm concerned. It was a disaster of a process, but I think the end product here is going to work just fine. So I'll just leave you with the outro that I had recorded basically minutes after I finally had my panels back on the roof. So I finally got the panels bolted down in a kind of ironic roundabout way. I've basically reinstalled them in almost the exact same fashion as the first set of panels. I just took like an extra day of drilling and messing around and swearing quite a bit to get back to this place. So should have just stuck with the original mounting method. I knew it worked. I wouldn't have had to drill out all these riv nuts and everything, but lesson learned. Anyways, thanks again to LightLeaf for helping me out. I absolutely love these panels, and you know, that was a pretty painful learning lesson about Loctite and plastics, and hopefully you guys found that part of the video interesting as well. So once again, thank you so much for watching, guys, and I'll see you next time.